Just a minute, okay? 1 minute, please. So, I need to bring on the music. So, guys, I think I need to apologize. One of those things that happen. Checking the audio. Okay. So, okay. Hi, Aaron. Um, no problems. No problems. I'm actually having some setup issue. My network seems to be my audio network seems my audio. Okay. 128. Okay. Sorry, please, 1 minute. One of those live, yeah, streaming live. One of those issues you face on my plans and all that. Sorry, I'm actually working on the audio synchronization with my voice. I upgraded to OBS. Okay, I think everything is set now, so we can continue. So, sorry, folks, I upgraded to a new version of OBS, and man, my both my both my bit rate and everything I've set, I don't know. OBS seems not to be obeying my setup, and it's really annoying. Whichever way. Sorry, this no, I'm not. I'm not. Just Aaron, I'm not. It's just more of an architectural discussion. I'm not actually coding. We just discuss about several other architectures. Then I'm not going to do coding for this live stream. Maybe the next stream I will be able to do coding. But I think at the end of the stream, I have a question that I needed to pull. So without much delay, let's begin. So I'm sorry, this is 30 minutes late. I didn't plan for this actually. There were one or two setbacks here and there, but whichever way. So the problem I had was that I updated my OBS, and it seems some things have changed, which is affecting my stream. Um, for instance, my bitrate seems not to be obeyed. It's giving me lower bitrate than what I set, and the network seems to be fine. So, so let me put on the background music so that I can hear it at my own side. Uh, okay. Sorry. Okay, so today what I want to discuss is just some architectural decisions that I've actually learned over the years. So, we are going to be, first of all, I needed to say this. The background song that I'm playing right now happens to be copyright free, so I don't need to receive any DMCA on it. And my setup actually is not going as I expected. I'm streaming to both YouTube and Twitch at the same time. I just want to experiment with this to see how it goes for today. So I'm not going to do coding today. No coding. I'm just going to talk about architectures, which I feel is important because by the time you start developing consumer app, you know, what I've learned over the years is that it's good to get your the structure of your program. It's good to get it right from start because if you don't get it right from start, if along the way maybe your CTO or someone that is in charge of the project decides to change the architecture, that means you are going to reprogram the whole thing because it actually happened to me. My my startup, my application actually when I was coding it, you know, when I had the privilege of getting access to Azure via Azure vSpark program for 3 years. So during that period, had access to what the kind of infrastructure I never expected, and actually did it starting from Azure Cloud Classic. Then I went to Kubernetes. I discovered along the way I needed to change the way I wrote my code to suit the the architecture that I chose at the end of the day. So to me, I feel before we start any kind of programming or any kind of building any kind of app or coding our ideas, I feel it's good for us to get the architecture right. So I'm going to show a few of architectures here. Hopefully, we won't spend more than 20 minutes on this. So, so what are we going to be looking at? Now, we're going to be looking at performance and scalability and the rest. And at the end of the day, how performant our application is also determined by the architecture that we choose. So there are various architectures that are available. I googled it and I was able to get more than 10. Out of the 10, I chose the one that I've used practically, not the one that I've not used at all. That's what I chose so that I can show them to you from the bottom of my heart, my experiences with it. So now, first of all, we need to define what's an architecture. Now, it says that it's a complex and carefully designed structure of something. That means we've defined how you want to build our applications. Actually, before it started things like microservices, before some individuals pioneered that kind of architecture, I'm sure all of us have done several things, but we didn't know that we're actually following this kind of pattern. But until someone sat down and thought of it, then structured it and put it together and made it available for us. So in software design, in software applications, called is the design and structure of computer information system or business application. And actual designs are actually reusable. What I mean by is reusable, for instance, if I was to actually come up with a particular architectural design and I make that knowledge free, then other people are able to use it. That it's not something that, okay, since I'm the one that have used it, since it is an architecture I've used, it's not something that you use once and you abandon. So we're going to be looking at various types of architectures before we get to our final destination. Actually, when I started without any architecture. That is true. Because when I was writing my code then, I was just writing code to just um, write code. Like, I think most programmers fall under these categories. Programmers that their duty or their job is to just code. They don't know any kind of any form of architectural design. All they are there for is code. So the first one, I first started out programming. I didn't know anything that had to do with architecture. So I was just programming my ideas. Like, I had this idea, given this task, how can I actually automate it? So I actually didn't start with any form of architecture. So it was along the way when I started having issues, complications, I began to learn several architectures. And the first one I actually used for my software application was Layered. And now this talks about the ability to separate your codes. I think I remember using window form then. Window form, both the logic and the UI was together with window form. So layered architecture talks about separating your components. Like for instance, if you are writing a front end, you know that okay, it's going to belong to the presentation layer where you have both the application service and both the UI. They'll talk about the business logic and the database access. All this, the purpose of layering your application is just for it to be able to maintain it. I think that is one of the key takeaways. By the time you follow all these architectural designs, the key takeaway is that you'll be able to maintain your application. And this application is suited for things like desktop app or mobile application. If you don't really care much about your business logic, because if you don't care much about people stealing your idea or people looking into your source code, that is, are leaving everything at the client side, I think it's okay for you to go with layered application, layered architecture. Both the front end, the business logic, the data access, and even the data is included in one device. So the next one you look at is client server architecture. When I wrote my application then with layered, I discovered one particular challenge. I discovered that they could one, my business logic is not actually safe, and I'm leaving it in the hands of people that could actually decode my code and reuse it. So this kind of architecture is recommended where when you don't want to leave your business logic at the front end. So that means your business logic is at the server, while the PC, the smartphone, and the laptop act as the front end, where you can have the UI and the code that accesses your server backend. So how will I put it now? This is more of an architecture that suits things like, let's assume things like a chat application, like WhatsApp, like Twitter, and the rest, where, for instance, you don't want people to actually see or steal your idea. And one thing about it is that if you are able to develop your application in such a way, you're going to lessen the burden in terms of maintenance. You know that okay, when it comes to compared to layered architecture, you know that when it comes to maintaining your front end, a different team can do that. Then when it comes to maintaining your back end, a different team can do that. I think that's why we have front end and back end developers. So all of your concerns are separate. The front end is separate from your back end. Then the next one is monolithic architecture. Now, one thing about monolithic architecture is that all the codes are in a single set of all your features are in a single set of programs or code. That means, for instance, looking at what you have on the screen, we have the billing, we have the trip management, the driver management, the payment, and the passenger management. These are different features of the of the of the of the program, all in one set of. So there's no separation to an extent of concern. That means if you are going to make any update to the billing, that means you have to deploy the rest of it. So if there's any change to the passenger management, you are going to also deploy the rest of it. And one thing about it is that order of execution is guaranteed here. That means if, for instance, um, I want to get a ride, I want to make a payment. That means this transaction have to wait for the previous transactions to complete before it will proceed. So order of execution in this kind of architecture is guaranteed. So that means we have, I think this is more suited to a full stack developer like me, because I'm able to actually code all the features in one project if you are using Visual Studio and the rest. Then the next form of architecture is microservices. Now, all these architectures, what they aim to do is to solve a particular problem. And what they aim to do is to solve the issue of maintenance. You know, it's difficult to maintain a layered architecture because by the time your codes begin to grow, you need to actually be able to break it down. You can actually go for monolithic where you separate everything into a particular, a different assembly, or you can go for a microservices where you have different teams working on different features, working with different programming languages. So microservice architecture I think it has its roots in domain-driven design, where we are advised to actually break down a complex domain into subdomains. For instance, if you have an accounting service, an inventory service, a shipping service, a storefront web app, instead of putting everything together, you separate them in their own different services so that different teams can work on them. So now building on microservices is the software architecture I'm actually passionate about, because at the end of the day, software pipelines actually get its inspiration from microservices. Hold on, please. Let me. So I need to check my streaming. Okay, so microservice architecture, all it talks about is the ability to break down a complex domain into smaller domain so that it's manageable and it can have different teams working on different aspects. Oh, I'm sorry. I didn't show the display. So sorry, man. Sorry. I'm sorry. I was carried away. I wasn't actually seeing what I was doing. So a quick run through. Mhm. Okay. Man, I have one sort of complex setup, and navigating between screens is actually giving me some tough time. Please, if you have any question, you can ask me. So, so we've looked at layered architecture where you separate your business logic from your application service, from your front end, and from your data access layer. We've looked at monolithic, where all the features that you have, if you are building a consumer app, for instance, where you combine all the features into one project. And the issue there is it becomes difficult to maintain when the project begins to grow. And since we are looking at performance and scalability, it now becomes difficult to scale. And performance as well is going to be affected. So microservice, I think what they did was they looked at monolithic and they looked at the issue that monolithic architecture had, and it came up with what we call microservice architecture, where instead of having to have a big mod of code, like they call it, we break the domains or the features into subdomains and have them run on their own service using a dedicated database. In that kind of case, now it's another way of increasing performance. It's another way of scaling your applications. But that doesn't actually solve the problem of wasted their CPU. I think what that talks about is I was reading something earlier, and it says that most business applications utilizes about 25% of their CPU. That is, that's on a single core. Now, if you now have like two cores, three cores, or even eight cores, that means the amount of wasted CPUs increases to about 75% to 85%. So, what software pipeline architecture actually seeks to solve, or is actually how can we take advantage of the increase in power? How can we develop our application in such a way that we are able to utilize, if for instance, we are currently utilizing about 25% of our CPU power, how can we actually utilize 100%? Because one thing about it is the the problem with CPU is that when they wait, once they wait at the same time, they kind of their level of performance reduces. So what software pipelines architecture seeks to do is to address such challenges. If you are able to use 25% of your CPU using layered architecture, using monolithic architecture, using microservice architecture, then how can you now further take advantage or increase performance? So that's what software pipelines architecture talks about. It's a way to implement parallel computing for businesses. It's technology to create a software pipeline environment specifically for business business applications. And what it says is that if you manage a critical application, I am mostly dealing with performance problems. So how can you boost the performance of the applications? I think software pipelines architecture actually set out to solve that kind of problem. So what software pipeline architecture actually encourages is, for instance, why I said that it derives its own architecture. I think it should come from microservices. Now, with microservices, you can actually, with software pipeline, you can actually break down the task of each domain and have it run in its own process. And why do I recommend software pipeline architecture? Is because one, it solves the need for parallel computing and reduce throughput offered by multi-core processes. Because one, the truth of the matter is writing a parallel application or logic is actually hard. Not a lot of people have the experience to actually write multi-threaded applications. I, for one, I don't have that much of experience because I've never actually needed it because I have libraries that I could actually leverage on. And also, it's actually very complex. Now, when you're writing multi-threaded application, you are dealing with a lot of complexities. Things like inter-process communications and debugging errors. In case there's an error, how do you actually um, how do you actually debug it? How do you actually know where the error is? I think that's one of the things that this kind of architecture helps us to take care of. And and to the I think this is the most important aspect of it all. It reduces long-term cost. That is the truth because if you have what's the essence of deploying what's the essence of deploying, like, let's say for instance 500 servers when you can only utilize 25% of what it can do. So, but with this kind of, when you develop your applications to follow this kind of architecture, you are able to reduce your cost, maybe by half or even more. So, now one thing about it again is that you are able to scale it from what a single CPU to multi-core, even to cluster of thousands of machines. And this kind of architecture has actually two fundamental components. The number one fundamental component is the pipeline. Now, you can consider the pipeline as a thread. That's why I said it helps us to actually build multi-threaded applications. So you can consider each pipeline as a thread. Now, it says that it's an execution facility for invoking the discrete tasks of business process in an order controlled manner. So what that means is you're giving, let's take an instance of microservices. You have your features running on different tasks. That means as request is being sent, it's going to be orderly. That is, as the message is being as the message arrives, it's your the pipeline processes it the way it arrives. It arrives not out of order. Like for instance, when you deal with let's say for instance the banking system. Now you want the pipeline to actually process authentication before you actually withdraw. You want the pipeline to actually check if this person has sufficient funds in his account before he actually withdraws. So those are the other controlled manner which we expect our applications to run. And the number one and one thing about it is now we're talking about software pipeline architecture, and what that means is a pool of pipelines. That is not, we're not talking about just one particular pipeline. We're talking about several pipelines in one, all coordinating to actually fulfill a particular request or actually make to improve the performance of our application. And the second one is the second component. The second component is the pipeline distributor. What that does is that now I think this is the most important aspect of software pipeline architecture is because when your request comes in, it takes your request and distributes it to each pipeline. So that's what it does. So here you can see now from this diagram, you can see that you have series of requests which is being received by the pipeline distributor, which further splits the task into individual pipelines. And one beautiful thing about this kind of architecture is that you can have a pipeline further send a request to another distributor, which also further splits the request into several pipelines. And one thing about it is pipelines architecture have rules. And one thing about pipeline architecture is that input must always equal output. And that is, for instance, if you have if your input rate is 1,000 transactions per second, then your output rate must also be 1,000 transactions per second. That is fundamental rule of software pipeline architecture. Or another way you can look at it is, okay, if you know you are going to be having like 1,000 available input rate, then definitely the potential output rate must also be equal to the input rate. And this is actually the diagram for it. You can see that our minimal flow. In this kind of case, the minimal flow, that means the input rate is not actually equal. That means the input rate is actually less than the output. And the optimal, that means the input rate is almost or equals to the output flow. And the second pipeline rule is this. It says that the capacity, that is the transaction rate of any downstream component or process must be greater than or equal to the input rate of any upstream. What this talks about is that, for instance, if I have a component that processes transaction, let's say 1,000 transactions per second, what that means is that it should be that component, the output rate should be more than the input. If not, we are going to create what we call backlog. And once there's backlog or once there's bottleneck, the system actually crashes. So the input rate must be less than the process rate. In that kind of case, so I will be able to deal with backlog. In this diagram, you see that we have, sorry, hold on please. Let me check my, okay, let me see. Sound is not clear. Oh, sound is not clear. Sorry, please. I'm having complex sector. I think I need to. Okay. Let me. Sound is not clear. So let me. Sorry, please. Let me need to. Okay. The check is loud. Um, I guess the background is louder. Doing live streaming is hard, very low, very low. Okay, let me see. Thanks for the feedback. Very low. Okay, actually very low. Give me a few minutes. Let me boost my audio. Okay, I think it should be better now. Then, let me come in. Hold on. Okay, so one more steps to go. Let me boost this by 10. Hello? Okay, I think it should be clearer now. That's one of the things of doing live streaming. So many things you need to take care of. So I'm sorry, I if I don't sound convincing, because this is actually I'm leaving my comfort zone. You know what that means? I'm leaving my comfort zone so to actually do this. So I'm not actually doing any coding for today. So I just actually really want to talk about um, the architecture I'm actually passionate about, because I'm going to from the beginning I said I think it's actually very important for us to get the architecture right before we develop any form of application, because this is what I learned from my own experience. Like I said, I spent about close to 9 8 years working on my own platform. So that means through that during that 9 years, I was actually rewriting, re-implementing, because one of the things that that really helped me was that I was admitted into Microsoft Azure Big Spark for 3 years. So before then, my knowledge of the only architectural knowledge I had it was more like a microservice architecture where instead of me using Kubernetes, I actually deployed my application in such a way that it's being run on multiple Windows services. So that knowledge, I took it over to the cloud. So, and when the night came for me to actually utilize Kubernetes, I also actually there to rework or restructure my application. So that's why I feel, because I could have said, okay, let's just write some codes, but I've discovered that writing the code is not actually the problem, but I felt like there's a need to understand where we are coming from. You understand? Before you add things like microservices, we had layered. I think that was one of the first thing I learned as a developer then back then is layered architecture, separation of concern, principle of we call it separation of concern and the rest. That one of the things I learned then. So how do I separate my, that's, I think that's where MVC came from. Okay, that was where MVC came from. Before then, I had something like web form, and I actually wrote web form, web application. You understand? Even then, WPF, where all my codes and everything lived in the same thing, in the same assembly, in the same process. Just that the when it comes to deploying, UI is actually different from the application service. So to recap, I've looked at layered application, layered architecture. I've looked at monolithic architecture, where you, I think to the extent that I actually use it, what I did was to separate or to break down my 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 codes into features, into modules. Like, okay, this features goes into this assembly, into this project. I think that would give me the foundation to actually understand all these different architectures. So from there, I went to microservices. So I have to check my comment session. Okay, better. Thank you. Icaros HQ. Sorry if I didn't pronounce that name very well. So please, I'd like you to help me. You can engage me in, I can ask me questions. I have to be honest with you. This is actually outside my comfort zone. So I don't like to talk about this kind of stuff. So I'm actually almost reviewing on myself right now. You get, so I think they say practice makes perfect. So this is actually my, and I think I also prefer doing live stream than recording a video and uploading it, because I actually tried to record and uploading. I discovered that my mind was just working like a stable machine. When I script a particular session, when I'm done with it, I actually delete it. I script another one, I delete it. So I prefer to just do live stream. Whatever happens, happens. If I get it right, so I think I just prefer this kind of method. So I'm putting myself on the spot, on the spot to make mistakes. And one thing about it is, with mistakes comes perfection as well. So, so please ask me questions, please, to help me, because there are things that I might not be able to actually clarify. So now we are looking at the number two rules for pipeline software architecture, and which is input rate must be less than the output. And from the diagram we are seeing, you can see that you have 1,000 transaction capacity. That is, you have a process or a component that actually handling a request at about, okay, handling a 1,000 request. Let's put it that way. Handling, you have a component or an assembly or a code or a logic handling 1,000 requests per second, and it needs to further push the request down the chain. This kind of, I will now have another component that actually slower than the input. In this kind of situation, what is going to happen is that the transaction becomes is backlogged, and at the end of the day, if you don't have what we call queuing, if you don't queue the request, then the process runs out of memory or crashes. So when we are trying to develop, okay, what software pipeline architecture actually talks about is, I think it's an architecture for us to actually utilize 100% of the CPU. So if you are able to achieve that, that means our application will perform better. Given that, it now has the same set of rules. The number one that I've looked at, we've looked at is that input must be equal to output. So if you don't have, what that says is that if you don't have enough requests, if you don't have enough transaction, then you don't need to actually implement this kind of architecture. Now, banking app might will be able to, because they have enough transaction per day or per second to handle. But if you're just writing just a desktop application that is going to be used by one individual, one user, then you don't need to waste your time to waste further resources, because resources is already being wasted. So you don't need to further waste it again implementing this kind of architecture when you don't have sufficient requests to handle. So what that means is now input must be equal to output, because what's the essence of um, receiving thousands? Let's assume what's the essence of receiving 10,000 transactions per second, and when you are outputting 5,000 transactions per second, it doesn't make sense. So that's what it's actually saying. Or another way to look at it is, what is the number, or what is the available number of requests? That is, if you have sufficient available number of requests, then you can go ahead to actually implement this kind of architecture. That was actually saying. Sorry there. So the second rule is that inputs must be less than the processing rate. So, oh God, sorry, I've changed the. I created the hotkey for transition. So anytime I press T, it actually changes to something else. So I'm sorry about that. So I need to check my chat right now for any question. Okay, so let's go on. Let's move on. Okay. So this is what it's talking about. That is so in a case where the input rate is not is more than the output rate or the process rate. That's what we call this the essence. I think this is where this pipeline architecture shines more. So it talks about, instead of having a bottleneck with one process, you can actually double the process. So what the second diagram is actually talking about is that, instead of, if you have an input rate of 1,000 and your process rate is 500, for instance, and you've optimized your code, it says that you should create additional pipeline to double on it, so that there is so there isn't any form of backlog, so that the input rate or the process rate can as well be less or equals to. So in our second diagram, you've actually implemented the first diagram is the problem that we are solving with pipeline architecture. So we are actually adding another pipeline to it with a distributor to distribute requests to route requests to other pipelines. That is number one rule. Then the number three rule. Now I was talking about the distributor. Distributor is just a facility, or it's just, in other words, it's just a rule to actually distribute our request. And one thing about it is that it can actually create, how do you call it now? You can actually create what we call, trying to remember that again. overhead, brother. Sorry, so it can actually create overhead for us. For instance, if and number one overhead is this: if you have, for instance, a distributor that is able to handle like 2,000 transactions per second, and the process rate is not is not as fast as the input is, then it's going to also bottleneck the whole system. So what what the rule is saying is, when you are writing your distributor, when you are writing your routing logic, make sure that it's actually faster than the process rate. So that's why in my previous video I talked about benchmarking. So when we benchmark our codes, we are able to know the rate at which our distributor is actually running. We are able to know the rate at which our process is actually running. In that kind of way, in that kind of with that kind of information, we can now optimize our code. So, so you are looking at three diagrams right now. The first one is optimal. That is, we have 1,000 transactions per second, which is that is we have 2,000 transactions per second, and we have 4 pipelines that handles the transaction. That is 500 transactions per second for each pipeline. This kind of way now, the inputs and both the process rate is equal or is greater. Now the second diagram. I think I have a message. Sorry. Okay, so this live streaming for you, getting used to it. Sorry, please hold on a sec. Okay, so we are back. Please, if you have any form of questions or any suggestion, please, I'd love to hear them. Because it will help me as well. So let's go back to our streaming. Okay. So the distributor rate must be greater than the process rate. In a situation where the distributor rate is or the process rate or the distributor rate is not greater, then it's recommended that we actually kind of distribute the load to create more additional pipelines. Let's move on from there. So now let's talk about Akka.NET, because at the end of the day, software pipeline is just it's an architecture, but the technology to actually implement it, I think that is the key. Software pipeline talks about splitting your business process into I would like call it into smaller tasks, and it talks about running it in separate threads across the CPU. But the thing is, it's just an architecture, it's just a design, it's just a structure. You actually need a library, you actually need a container, you actually need a module for us to actually implement it. And Akka.NET actually helps us to do that, because one, With Akka.NET helps us to write multi-threaded application, one, and also Akka.NET helps us to also write distributor. It has a router, like router pool and the rest. So Akka.NET can act as a framework, as a library for us to actually, hold on, skipping something. To do that. So that's what Akka.NET does for us. It has all the features that we need. It has the routing logic for us to use. It has the ability for us to run our code in a dedicated process. And one beautiful thing about it, if there's any issue with a particular process, when it crashes, you can set it up in such a way that it restarts. So that's having said that, we also have to look at, should I actually say this? Okay. Sorry. Oh, I'll change it. Okay, so the why we choose, when we want to actually write software pipeline architecture, we need the tools, we need the framework that help us to actually do that. Because the truth is, software pipeline architecture cannot be achieved, because if we are to write our own code by ourselves, there's going to take a lot of time and a lot of effort. But since we have the architecture, we have the design, we have the diagram, what remains for us to do is leverage on a ready-made tool for us to do that. So in this streaming, I'm not gonna actually code. I just want to actually talk about the architecture, talk about software pipeline architecture, show the diagrams, and so that when we start implementing the code, you understand the reason why I'm doing certain things the way I'm doing them. Like I have always said, that if you are writing any form of application, I think from my own personal experience, not that I heard of it or someone told me, from my own personal experience, it's always good to decide on which architecture to use. And for me, except if I'm going to write an enterprise grade, an application is going to be used by several individuals, I think I will go with software pipeline architecture. But if I'm going to write a simple application that I don't need, maybe that doesn't need much functionalities, doesn't have much features, then I'm okay with layered architecture. Because it's not actually in every cases that we use this kind of architecture, but in case you have, let me return to this slide. Okay. So in case you are dealing with performance problem, if you're a business owner, you are working with an enterprise company, or you are dealing with a business application that is actually, the loads is actually affecting it, or it's not scaling the way you want it to scale, or it's not it's the response rate is low, then I think software pipeline architecture is for you. It can handle ever increasing data volume. That's one beauty of it. So I displayed this slide so you understand when and where you need to implement this kind of architecture. It's not actually for every kind of software or every kind of product. It's actually for product that actually have a lot of high data volume, high traffic rate, high users connect, like for instance ATM, for instance maybe IoT device, metric and all that. So it's actually meant for it, because the beauty of it is, if the vendors have actually increased the processing power of our computers, then we as a developers have to find a solution to actually take advantage of it. And software pipeline architecture seems to be the solution. The truth be said is, I'm coming now. After everything I've said, I need to give credit to whom credit is due. I'm not have presented this idea the way it ought to. But one thing about it is, I actually learned this kind of architecture from Corey Isaacson. I think he's him and his company that one that pioneered software pipeline architecture. It's, with everything I've said, this is just more like an introduction. I'm not an expert in it, but I just felt like, not that I want to show my knowledge, right? But I just felt like the little idea or the little light I can shed in some of the performance and scalability issues that we as the developers we are having would go a long way in inspiring the next developer. The book has actually inspired me. This is not actually my domain. Oh, sorry, God, why is this doing like this? Okay, this is not actually my domain. To be honest with you, this is actually, I'm coming out of my comfort zone to do this, to talk about this, which I think, well, I might not have exhausted all you have to say, but I started late, and I think I probably took more than I expected. I was thinking maybe within 20 to 30 minutes I'll be through, but happens that I'm not that good in presenting things like this. So one of the things I need to improve on in my next stream. So I'm giving credit to whom credit is due, to whom honor is due. Corey Isaacson is actually a pioneer of this thing that I've talked about. When I started learning how to program, that was 2008. The book was actually released 2009. So then it was too fresh out of the oven. So when I studied it then, it was too fresh out of the oven. You get, so my adventure into Akka.net actually made me to really, really appreciate what the work he did in that book. So if I was to work in a team that has to do with that have to do with high traffic application, I think this is one of the architecture I recommend, because one, apart from tackling wasted CPU resources, that is, you have a CPU, you're utilizing about about let's say 25% of it. That is, you are wasting a lot of money. You are paying for what you're not actually using. If you are using, for instance, Kubernetes, but this technology helps us to actually this architecture helps us to develop applications such a way that we are able to utilize 100% of our CPU. And the beauty of it is, when this book was actually written, it was 2009. I think Akka.net has not even come out then. And I don't think they are aware of Akka, that is the Java of Akka. Because the truth is, they actually wrote their own code by themselves. So I'm not actually looking at the code. A lot of the work that I would have done if I was to follow what they wrote has actually been executed for me by the Akka team. So what I need to do is, instead of me spending like 100% of my time writing a framework that actually helped me to leverage on this kind of architecture, what I can do is leverage on a ready-made library to actually implement my own architecture. So on that note, I will have to say this. I don't know, but on that note, I would like to ask a question of you, which is this. For my next stream, I'm going to be coding, because I'm going to be coding. I'm going to be coding. So I want to know, what do you think I should do? Because the book talked about an ATM, uh, the example of the software pipeline architecture that it actually used was an ATM example. So my question to you is, to those that is doing it now and to those that will view it later, should I come up my own example? And for those that will have that will get the book to follow along, you can get it on Amazon to follow along. The question I have is, because since the code there was actually written in Java, should I put the example written given in that book to C Sharp, implement it with Akka.NET, or should I come up with my own fresh idea? Because what I'm actually trying to do is to avoid plagiarism before I'm giving a DMCA. So I'm trying to avoid that. You get, but in any way, if it's something that is doable, then I can do that. So let me hear what you have to say. And please, I need your feedback. Where can I improve on? Because this is not my comfort zone. You get, so this is not my comfort zone. The reason I did this because I felt like, how do I actually pass across how do I actually pass across my my passion? So I actually talked about it. Let's look at various architectures, and that's why I started with no architecture, which was the first thing I said. Because as a developer, when you're starting out, the thing is, you don't know any architecture. All you know is, how can I do X Y Z? How can I implement X Y Z? But and if you are working in a team that they're actually choosing the kind of the way they will deploy it or the way they want to structure their code, then it becomes a problem when all of a sudden someone comes and say, "Wow, let's do microservices." After you've implemented your code without any form of, you don't know what you want to do. You look at it, okay, to actually do this, you need to change this line of code, you need to do that. You get. So I think that is, from my own experience, I know that once you don't get the architecture right from the beginning, then it, it becomes a problem. For instance, now, when I was googling about this, I heard of space-based architecture and microservices. What do you call it? Okay, nano services. I heard of those two. And if actually before then I've already been writing my application to be microservice to be structured with microservice architecture, and I come across space-based architecture, and I come across nano service architecture, I'll be like, and I like that kind of architecture. That means whatever work that I've done previously, I need to go back and maybe I might not change my code 100%, but at least to an extent, I will change the code to actually fit into the architecture that I want to work with. So that's just it. So that is my purpose to of sharing this. And one thing I've always done when beginners actually ask me how how they can be good in what they do, I always tell them, start with an idea. Apart from, I know nowadays we talk about data structure, um, algorithms, all the tests online, how you do data structure, how you do and all those things. I'm not against that. That is beautiful. But also start with an idea. Try to implement your own idea. In that kind of case, now you learn so many things. Not just about the logic, not just about the 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 code. You learn how your code will be deployed, and you learn what happens when you actually change the architecture in between. So that's just what I have to say for today. Wait, should I rate myself? Okay, if I rate myself, I think I'll give myself 4, because I don't think I did justice to it. But in any way, I introduced an idea that I think some people might have heard of this kind of architecture before, and some might have not have. You get, and so this is just what this is my way of just okay, not keeping it a secret. You get, and this is also my way of encouraging others to actually look into Akka.net. Now, if you are to follow the rules of software pipeline architecture, if you are to follow the design of software pipeline architecture, you discover that now Akka.net actually does a lot more for you. That is just the truth. Not that I love Akka.net. I will keep saying that. I keep saying that. You get, not that I work for them, but notwithstanding, it's an open source. It's an open source, but open source software, and you need to appreciate it. You need to appreciate open source software because when I started, when I started programming, then we didn't have much open source project to leverage on. That's just the truth. There was no much open source project to leverage on, and I think that's one of the things that actually affected the software pipeline architecture because as soon as they've known about Actor model, or maybe they've known about Akka.net, or if they've known about Akka, the Java implementation, then probably they would have bothered writing maybe 50% of the book. They'll have written maybe probably just about few percent, maybe 25% of the book. Because a lot of the effort, a lot of the energy has actually been implemented as an open source. So what you need to do is just take the library, look at it. Number one, what are the basic components of of software pipeline architecture? It's simple. The first one is the distributor. What that means is now Akka.net on Academia has already given us the leverage, has given us the foundation. Okay, we can actually run our application in a dedicated task or rather process. We can actually run our tasks to be multi-threaded to take advantage of multi-core processor or even hyper-threading and all that. We already know that this tool gives us this feature. The only thing we now need to do is to look at it. Okay, how do I implement a distributor with Akka.net? I think that's the question now. How do I implement a pipeline with Akka.net? I think that is the question. Then you now begin to structure your code in such a way. So, but the thing is, I'm just letting you all to know that okay, this kind of thing exists, so that you can look into it and use Akka.net to actually achieve such architecture. So this is where I'm going to call it quit, or like this. This is where I'm going to end the stream. So please, I know at times feedback would hurt, but part of it anyway. If I really need to come out of my comfort zone, I think I need to be doing more of talks and less of coding. So the next stream I'm going to do, I don't know when, but I think will do coding. We'll code, like I said, we've looked at the rules and we looked at the structure and we looked at all the things we need to do to actually achieve this kind of architecture. So the next one we're going to do is actually implement it. So now I've already asked you a question. If you have access to the book, it's in the book. Corey gave an example of an ATM bank machine. Now I don't know if I should implement the same thing or I should come up with my own idea because in the last video, in the last streaming I did, I tried to come up with my own idea, but I think for context or for comparison's sake, I think at times it's always good when you are trying to teach people something to actually do it the way the original author did it, so that when they look at your code and look at what the author wrote or did, the only difference will just be the language, not the implementation. So I think so. But let me hear what you have to say. Please leave the comments And again, my name is Ebere Abanonu. So see you all next streaming. Bye. So see you all next streaming. Bye.